You wanted the best. You've got the best podcast. The hottest podcast in the world. The Chris Voss Show. The preeminent podcast with guests so smart you may experience serious brain bleed. The CEOs, authors, thought leaders, visionaries, and motivators. Get ready. Strap yourself in. Keep your hands, arms, and legs inside the vehicle at all times, because you're about to go on a monster education roller coaster with your brain. Now, here's your host, Chris Voss.
Hi, folks. It's Voss here from thechrisvossshow.com, thechrisvossshow.com. Welcome to the big show, my family and friends. The Chris Voss Show podcast, the family that loves you but doesn't judge you, at least not as harshly as that one time you dropped the soup at your mom's house or something. I don't know. I'm just making up stuff at this point. It's always the ramble. We just make up stuff as we go along. But remember, you're never alone, ladies and gentlemen. We always have at your disposal with the Chris Voss Show podcast 2 to 3 episodes a day, 10 to 15 episodes a week. 15 years, 1,500 episodes, plus going on 16. What more do you want from me, people? Jesus. Anyway, there's always stuff for here. So if you ever feel need to feel wanted, loved, like you're a part of something much bigger than yourself, and people just kind of accept you for the way you are, unless you're a really evil person, like you're a dictator of some country, we accept you and we love you. And therefore, we want to guilt and shame you. As always, this is a setup for the plugs. Go to youtube.com/Chris Voss. Tell all your friends, neighbors, relatives, and family to go to goodreads.com/Chris Voss, linkedin.com/Chris Voss, tiktok.com/Chris Voss at 1, and all that good stuff. We are going to be having some fun today, boys and girls. Boys and girls, listen to this show. What is it, YouTube or TikTok? Anyway, boys, girls, ladies and gentlemen, people of all ages, welcome to the Circus Tent in the Sky, as the Barnum and Bailey brothers would say it. Were they brothers? I don't know. We'll have to look that up. We'll check with the lawyers. We're going to be talking about planets today. You ever been like me? You just sometimes sit up late at night and it's about 3 a.m. and you can't sleep, and you're like, what are planets? What the hell are they doing up there? And they're always looking at me. They're always looking at me from the sky, judging me and stuff, stars and shit. And I'll go outside and I'm like, hey man, quit stalking me, eh? Like, why are you always watching me? That Big Dipper is always stalking me. And I'm just like, hey, can you guys look away? I'm going to go pee in the yard. So there's always that, it's kind of like they're just always watching, like, hey, do you guys got something else to do? Like, look at something else. It's a big universe, people. So you ever sit there and lay in bed going, what are exoplanets and planets, and what happened with that Pluto thing? Is it a planet? Is it not a planet? When is the sun going to burn out? If you live through this summer, the sun was about 5 feet from our planet most of the time. So these are the things that I ponder in the middle of the night, and I think you do too. And we have just the man who's come on the show for the answers in his latest book that's just come out July 11th, 2023. And he may be correcting how close the sun was. It may have been 10 feet instead of 5. His newest book has just come out, The Little Book of Exoplanets. Joshua N. Winn joined us on the show today, and we're going to have a lot of fun with this, because normally we talk a lot about business and life and novels and everything else, but rarely do we get into the planets, as they say. Josh Winn is a professor of astrophysics at Princeton University. It's going to be a really smart discussion, ladies and gentlemen, and not for me, because I'm just a dumb host. His research goals are to explore the properties of planets like no man has gone before. Wait, is that another line? And other stars. He wants to understand how planets form and evolve and make progress on the age-old question of whether there are other planets capable of supporting life. He's also a member of the team that built and operates NASA. You may have heard of these guys. They shoot stuff in the sky. NASA's ongoing Transitioning Exoplanet Survey Satellite Mission. Welcome to the show, Josh. How are you?
I'm doing well. Thanks for having me on.
There you go. We did a fun little ramble, meandering thing there for you. Give us your .com so we can find you on the interwebs, please, sir.
Oh, I have a Princeton University website. So if you just Google Josh Winn Princeton, you'll be brought there.
There you go. There you go. So what motivated you to write this book?
Well, like you said, almost everybody has had the experience at some point of looking up at the sky, seeing all those stars, and wondering what's out there. Are there other planets around those stars? Are they anything like the Earth? And a lot of people are surprised to find that we actually can answer a lot of those questions now.
Ah,
We know of more than 5,000 exoplanets, that is, planets, but they don't orbit the sun. They orbit some other star in the galaxy.
what's with that, man?
Well,
Why they got to be like that?
they're really far away. They're very hard to detect,
Mhm.
and it's a booming field. It's very technology driven. It really only got going in the mid 1990s.
Hmm.
And it's one of the hottest fields in astronomy.
There you go.
So
So so go ahead.
basically, I wanted to provide a complete briefing to anybody who's interested in this fast moving scientific field.
Hmm. So are exoplanets basically like the normal planets we see in our little speck of the universe, but they just don't revolve around the sun? Then that's the definition. I want to clarify
That's
that.
right. A planet in general is a object that's much smaller than a star, and it orbits a star.
Hmm.
So we all grow up learning that the sun and our solar system has 8 planets, or
Hmm.
if you're above a certain age like me, you learned that there were 9 planets. And when you're in elementary school, you tend to learn the names of the planets and what they're like. You learn that Saturn has these beautiful rings and so on. Well, exoplanets, we know less about them. But
Wow.
despite that, because they're so far away, they're very hard to study. But despite
Yeah.
that, we've seen that there are a lot of planets that do not resemble any of the planets in the solar system.
Mhm.
And that's part of the fun.
There you go. Have you tried texting them or seeing if they have an account on Twitter?
I
Maybe you
wish.
can reach out to them
Yeah,
that way.
yeah. Communication is even harder. Yeah.
There you go. There you go. So the rest of the they're placed in the universe that don't revolve around the sun.
Yes.
That's very interesting. The universe is very diverse, which
Yeah.
is really interesting.
So if your conception of the universe is that there's a sun, there's some planets going around it, you
Mhm.
really need to zoom out and widen
There
your
you go.
perspective, because we live inside a galaxy, the Milky Way,
Mhm.
that has something like 100 billion stars, all circulating around the center.
Mhm.
And the Milky Way is one of some countless number of other galaxies.
There you go.
So,
Yeah. In fact, they just recently discovered curry on the moon. India landed there. That's a joke.
that's
People
useful.
did.
Yeah.
Yeah, there you go.
Okay.
And hey, there's a billion people or something in India. Who knows how many people? There's a lot, and they're going to need curry if they go to the moon. So give us a 30,000 overview of the book. What's inside of it, like a synopsis, then we'll get
Yeah.
into some of the deets.
So the book is about what we know. What do we have evidence for? We all grew up with science fiction that invite us to imagine the properties of other planets and how they might be different and interesting. But what do we actually know, and how does it compare to science fiction? And where is this field going? So we talk about, how do we detect these planets? What is the evidence that they even exist?
Hmm.
And what are they like? What would it be like if we were there looking at them? What do we know about these planets' sizes and atmospheres and that sort of thing?
What they post on Instagram. Yeah.
Yeah, that's right. And where are we going next? Are we going to find planets just like the Earth? How will we ever know if there's actually life on those planets?
Ah.
Those are the big questions that this field is approaching answers for.
Are they flat like are they flat like some people think the Earth is, but everyone knows the Earth is square. It's not flat. That's
Yeah, we haven't found any flat planets. So far as we can tell, they're all spheres.
wow. What's
But
that about?
but another thing is that if you zoom out and look at the solar system is, in a sense, flat.
Really?
It has all these planets, but the orbits of all those planets are all aligned with each other,
Wow.
making a flat plane, and all the planets orbit within that plane.
You just
It's
started
kind
a
of-
whole new conspiracy group.
Yeah, the Earth is not flat, but the solar system is flat.
Yeah, everyone knows it's square.
Yeah.
It works on the square rotation. It's like a Rubik's cube. You know, that's how the sun shifts around the Earth. I'm just making this up as I go along. The Rubik's cube. That's why the waves in the sun. You know, it's God shifting the Rubik's cube as it goes around. It doesn't really spin. It's just God spinning the Rubik's cube. Yeah.
Fascinating.
Yeah. If NASA ever wants me to come speak there, I just made that up. It's kind of funny though when you think about it. But we just probably started 2 new conspiracy nut job groups. So tell us a little bit about your origin history. What made you motivated to get in this field? What made you grow up and say, "Hey, I want to work at NASA and do science stuff"?
Well, when I was a kid, I was totally into space and stargazing and learning the constellations and reading books and magazines about the astronauts and the Apollo project and all kinds of exciting things like that. But it wasn't until much later that I decided to be an astronomer. That was not until graduate school, really. And then I wasn't working on exoplanets at first. In fact, nobody really was until the late 1990s. And so I got my degree in 2001, my doctorate, and I was working on something different, but there was just so much excitement in this field because of all of these new technologies and new advances that I felt like it was a great time to switch over. And
There you go. Was it because we got better at looking at the stars with like the Hubble scope and different things like that? We could see a little bit further outside of our windshield.
It's totally technology driven. Every time, so all we have is starlight. That's the frustrating thing about astronomy. We cannot go out there and visit these other stars or bring them back for laboratory analysis. So everything we learn is only because we can analyze the light that reaches the Earth. And that's what telescopes do. Telescopes are machines for dissecting and analyzing light. And every time we come up with a new technology to make more precise measurements, we find new planets, along with all kinds of other new astronomical phenomena. So yeah, you're right that Hubble and the large telescopes that we have at our best observatories on the ground, the new space telescope, the Webb telescope, all of those are crucial for learning more about these objects.
There you go. So which ones do the aliens come from?
Oh, I wish I knew. Right? That's one of the big motivating questions in this field is there life elsewhere? Are we alone?
Yeah.
And I don't have an answer to that question, but it's certainly part of the answer that we are starting to learn about the planets. We think that if there is life out there, it's probably on a planet. That seems like a pretty good place for chemistry and biology to take place. And so we're learning a lot about the planets and some ways in which they resemble the Earth. But we don't yet know of any that are inhabited. And it might take us decades or more to be able to really perform a very sensitive search for life around other stars.
There's got to be intelligent life in this universe because we need hope, and there's none here. So there's that.
I mean,
the intelligent part.
I'm not as pessimistic as that, but I do agree that given the numbers, it would be very strange if there were not life elsewhere in the galaxy. I just said a few moments ago, there's 100 billion stars. Right? That's a lot of opportunities for life to develop. But if you ask a different question, is there life within, say, 20 light years of the sun that is close enough for us to actually communicate within a human lifetime? Now you don't have hundreds of billions of stars. You only have a few hundred.
Yeah.
And so my intuition doesn't tell me whether there is likely to be life or not with just a few hundred tries. So I don't know.
Maybe we can get Elon Musk to give up that Mars thing, go to an exoplanet for it. That sounds funner.
That would be awesome.
And then the Exo, see the brand thing, the branding, because now it's X. Twitter is X.
That's right.
See, this is a sell. You should call him.
Well, I mean, the sad fact is that it's hard enough to get to Mars, right?
Yeah, let alone call Elon Musk. Yeah.
A rocket ship going to Mars takes like a year or a year and a half or something like that with our best rockets today. To get to the nearest star, which is called Proxima Centauri, that would take about 10,000 years with one of our current best rockets. So, it's not just a small technological advance that we would need. We would need a huge leap in order to be able to visit exoplanet systems.
There you go. Maybe Ferrari or something. Some
really souped up Ferrari.
Yeah, there you go. Turbo, extra turbo.
Extra turbo.
Cool. So let's get into some more of these deets about the exoplanets, because I had never really heard about exoplanets before. And this is the beauty of what you're bringing to us is the education. What do we need to know about exoplanets, and do they come in peace?
Yeah. We'll take the first question. Okay.
Sure.
What do we know about them? Well, a lot of what we know about them is related to how we detect them. We have very limited knowledge about these exoplanets. I cannot show you a picture of the surface of any exoplanet. Even with our best telescopes, we cannot see exoplanets as more than just a single point of light. And sometimes not even that. In fact, most of the time, not even that. So how do we even know they exist? The simplest way, conceptually, is eclipses. So every now
Okay.
and then, the planets are orbiting stars.
Mhm.
And every now and then, a planet's orbit happens to carry it right in front of the star from our point of view.
Oh.
And we can't see that happening, but we can see that the starlight drops a little bit in brightness when the planet is blocking some of the light. And then
Oh,
that goes
wow.
away. And every time the planet wheels around, we get another little dip in brightness. And
Mhm.
we've gotten very good at measuring the brightness of stars precisely. So, in fact, most of the exoplanets we know about come through that method, the
Wow.
increased sort method. And so, what do we learn? Well, we learn how big the planet is from how
Yeah.
much the light drops, how much light is blocking.
Ah.
And we learn how long it takes to go around because we can
Mhm.
see it repeating over and over, and we can measure the time between those events.
Mhm.
So, those are the two most fundamental things we can learn: the size of a planet and the time it takes to go around the star.
Mhm.
And we have planets the size of the Earth, we have planets the size of Jupiter, and we have everything in between. We also have planets that are at Earth-like distances from the sun,
Mhm.
and we have planets that are much farther away, hundreds of times the distance of the Earth to the sun. And we know of planets that are extremely close to their stars, almost ridiculously close,
Wow.
with orbits only 1/100th of the size of the Earth's orbit. So they're parked so close to the star.
Wow. And is the orbital pattern of, the stars and the exoplanets, is it similar to ours? I mean, at least in some way or another, where they revolve around each other, or is it
Well, they're
sometimes they're just
similar.
hanging out or something? Or?
They're similar in that the planets revolve around a star. Like that,
Mhm.
that's pretty much guaranteed by the basic laws of physics. But they're very unlike the solar system in the patterns. Like, for example, if you pick a random star like the sun,
Mhm.
there's a 1 in 3 chance that it has a miniature version of the solar system where all the planets are crammed in to what would be Venus's orbit or Mercury's orbit around the sun. So you might have
Oh.
5 or 6 planets, but their orbits are all tiny.
Uh-huh.
And so that's very unlike the solar system, which is much more spread out.
Mhm.
And there is a small chance, like a 1% chance, that it has a Jupiter sized planet,
Mhm.
but it's really close to the star. It's orbiting just about as close as it is physically possible to be to the star.
Wow.
That's a whole new category of planets called hot Jupiters. Not a
Hot
very
Jupiters.
creative name. Yeah. They're like
I think I
Jupiter.
saw some of those on Tinder.
Yeah, that's right. Very hot Jupiters. And we don't know where they came from. In fact,
Ah.
there was a very well investigated theory of planet
Mhm.
formation that said such planets should be impossible.
Mhm.
And yet they were the earliest type of planets that were discovered.
Wow. Hey, let me ask two dumb questions.
No such thing,
And
but go ahead.
well, I'm having some fun here. So, is it? Do we? We're made up of what, matter or whatever the hell it is, or we're
Adams,
made up
yeah.
of atoms and stuff. It is and oxygen, and do you need an environment like ours to create some form of life, whether it's based on how we're based or not? Or is there life on other planets that is, like worms or molecular crap or, you know,
It's a good
I don't know.
question. It's not a dumb question. It's kind of the big question.
I flunk science.
Yeah. But the answer
Well,
is we don't know.
okay.
If we knew how life got started on the Earth,
Hmm.
we would be in much better shape
Yeah.
because we could look for those same necessary conditions here elsewhere. But we don't even know how life got started on the Earth.
Yeah, but isn't there a book about it 2,000 years ago or something? No, I'm
Yeah,
just kidding.
that's
I'm an
true.
atheist.
There are various opinions, but
Okay.
there are some clues, right? It seems pretty
Yeah.
clear that life started in the oceans
Yeah.
because that's where the most ancient fossils come from, and that's where the most, there's a progression of life in the earliest stages seem to have been in the oceans.
Hmm.
So our working assumption is that you need liquid water in
Mm.
order to have a chance of forming at least Earth-like creatures.
Yeah. That's what my
Life,
doctor tells
life
me.
as we
8
know it.
classes a day.
So that's why we get really excited whenever we discover an exoplanet that seems capable of having liquid water oceans.
Oh.
That is, It's small enough that we think it probably has a solid surface. It's not like Jupiter or Saturn that's all gas. And it's the right distance from the star, so the temperature allows for water to be liquid instead of freezing if it's too far away, or boiling if it's too close.
Evaporating probably too.
Yeah.
Yeah.
So that concept is called the habitable zone. If we find an Earth-sized planet in the habitable zone of its star, then we get very excited, because that is a potential place where life might arise.
There you go. Yeah, to me, it's just so interesting. I remember as a kid looking at the stars, and I used to shoot off the SS rockets.
Oh yeah,
I love NASA. Awesome. I think I had the space shuttle at one point, and I don't know how old you are, probably around my age, but we grew up in that golden era of the space shuttle and how magical that was.
Definitely.
It just rockets and space travel and all the really cool stuff. What's the future hold for us? I imagine NASA's working on more. I know they have a new advanced telescope that's bringing back incredible images.
Yeah.
They're probably just going to keep, they're probably going to be like Canon, where they just keep coming out with better resolution, the cameras and stuff.
Like I said, it's all technology driven. So the here and now, like you said, is this new space telescope. It's called the James Webb Space Telescope. It's much better in many ways than the Hubble Space Telescope. And one of the things it's good at is not only detecting the evidence for planets, but measuring the contents of their atmospheres. It can tell us whether a certain planet has, methane in its atmosphere, or carbon dioxide, or sulfur dioxide. It can measure some of the molecules that exist in the atmospheres of these planets. That's happening now, and it's very exciting.
There you go. Hey, is that to fall back to what we mentioned, hop back a bit in the conversation about water? Is that half the reason they're looking for water on the moon, and see if maybe they can find some semblance of life, or is it just make a way station?
No, it is the reason why everybody's looking for water on Mars, because Mars, is arguably habitable. It's colder than the Earth, but it's not outrageously colder. And so maybe early in its history, it did have liquid water oceans, and they were lost for some reason. So people look for water on Mars because they're looking for life. But on the moon, we already know there is water, but there's so little of it. It's incredibly dry.
Yeah, it's very
doesn't have an atmosphere at all. It's very uninhabitable. So the reason that I've read, anyways, that the space program is so excited about water is because one day that might be useful as fuel, or a type of, in order to sustain a base.
There you go.
So in order to provide, I guess, drinking water and water for other uses of a permanent base on the moon. And you can also imagine doing other things with water that would be useful, using it to store energy, for example.
Well, when I was growing up, the cartoon said the moon was made of cheese. So can't they squeeze some of that cheese and get the water out of it?
The cheese hypothesis has pretty much been ruled out.
Damn it. I got to read the news more often. Yeah. I'm like people are with politics. They don't pay attention to what's going on, and then they find stuff out. So it's not cheese. Damn it. Now I'm not going to be hungry anytime I look at the moon anymore. But
getting back to your question about, is water really essential? The truth is we don't know. We need to keep an open mind because we don't understand life on the Earth. But at the same time, we have to start somewhere. We have to prioritize certain planets for the search, and we might as well look for the ones where it evidently worked at least once. Planets that resemble the Earth. That's the thinking, anyways.
We can see if there's lightning struck twice, maybe. I don't know. I think we need a telescope to look back on our planet and try and find intelligent life. I'm a big purveyor of love of the George Carlin bit.
Everybody's heard of Carl Sagan, right? Carl Sagan, in 1993, he pretended to do that. He pretended with his group to be alien astronomers looking back at the Earth, searching for life. They used data from a spacecraft called Galileo that was really exploring Jupiter, but incidentally, it got some data looking back at the Earth. And so Sagan and his group kind of pretended, well, let's say we only have this data. Would we know that Earth is inhabited? And it's actually not obvious. It's not so easy to detect. But what they pointed out is you can see that there's oxygen in our atmosphere, along with other molecules that really shouldn't be there for very long unless there's some process that's constantly putting it there.
Mm-hmm.
And so they took that as kind of evidence that Earth really does have life.
Mm-hmm.
And that inspires a lot of people as a way of finding life on exoplanets. If we see oxygen in the atmosphere of some Earth-like exoplanet, maybe that's because there are plants on that exoplanet that are constantly putting oxygen in the atmosphere, just as plants here do that for the Earth.
There you go. It's what were the chances? Recently NASA did that thing where they sent a thing to an asteroid.
Yeah, they slammed a little rocket into an asteroid.
Yeah. That was pretty damn cool.
I agree.
It was cool to watch it down to the last second. You're just like, this is awesome, man. Yeah,
that's right. It goes closer and closer, and then static across the screen.
Turn that whole one movie with Bruce Willis into a documentary. That was awesome. What's the chances we can have that anytime soon with an exoplanet?
Like I said, it's not going to happen soon. Unless we're totally wrong about the laws of physics and we can invent some kind of hyperdrive. We don't know of any technology that will get us to distant stars, that's just way outside the solar system, within a human lifetime.
Yeah. Maybe we need to create like a breeding farm, put people on a planet, and they just keep breeding as the plane flies, and then their grandkids will land on Mars or something.
It's a great concept from science fiction. That is,
sure,
you just build a multi-generational spaceship. So it takes 10,000 years to get there, but maybe somebody will still be alive on the spaceship when it arrives, and will remember why they were sent in the first place.
Why are we here? I don't know. Mom said it was important.
Because even the nearest star, Proxima Centauri, is a little more than 4 light years away. So even if we could travel the speed of light, it's 4 years to get there. Wow. And we cannot travel the speed of light. We can only go much slower than that with our current technology.
There you go. Well, maybe the only problem is, halfway through, somebody probably get divorced and get sick of each other and want to move out, and so that would cause a problem since you're on a
10,000 years is a long time for a group
tube in the sky. Yeah, that is a long time. I mean, I know people who can't get 5 years in a marriage. Yeah. So there you go. What have we talked about, or what have we touched on that we should tease out about the book?
Well, a lot of the book is talking about some of my favorite exoplanets. And
so you have favorites.
How do we know about their properties, and why are they weird? Because I've been talking so far about the search for Earth-like planets, and that's great. But actually, a lot of what I do personally in my research group is about the weird planets, the ones that we're not expecting, and don't really have any analogs here in the solar system.
So kind of the kinky ones, then.
Yeah, that's right. So
there's an OnlyFans, I think, going on.
Yeah. So there's a lot of them. So, for example, there is a planet. Goes by the bizarre name of KOI 1843.03.
Oh, I know that one, yeah.
Yeah. And it is so close to its star that it goes around, not every year, it goes around every 4.25 hours. So the year on this planet is only about 4.25 hours on the Earth time. It's so close that the gravity from the star is probably distorting the planet. So it's not a sphere. It's really elongated, kind of like a football.
Oh, wow.
So it's right on the brink of being destroyed, of disintegrating because of the gravitational field from the star. And yet there it is. And it's probably been orbiting there for billions of years.
Wow.
So how did that planet get there? What caused it? It probably didn't form there. It's too close to the star. So, but if it formed farther away, like the planets in the solar system, like what pushed it there? And then why did it stop? Why didn't it just fall into the star? So that's the kind of question I find interesting. And it's teaching us something about planet formation and all the things that can happen within a planetary system, even if they didn't happen in the solar system.
I just think I solved the mystery of the universe. And what you're talking about is why did the star stop there and stuff?
Yeah.
God is playing pool. And if you ever played the game of pool, I was just playing this the other day. Sometimes you hit the balls and the rack just goes, and it goes everywhere.
I like that.
Stuff stops in random places.
That's right. So that's a nice metaphor for one of the theories
for billiards in the sky.
Yeah. So a lot of exoplanet systems have planets on weird orbits, like really
Yeah.
short period orbits, really misshapen orbits that are more like elongated ellipses than circles. And a lot of the theories for how that happens is kind of like playing pool. You take a bunch of planets, but they have encounters with each other.
Yeah.
And if two planets come close enough together, they can actually smash into
Collide.
each other, or they can at least deflect each other's orbits because of their own gravity. And that might be what is randomizing the orbits in some of these exoplanet systems.
That's what those asteroids are that come shooting through the thing, go by us, and we're like, whoa, holy crap. Movies
right.
of Bruce,
If you have,
Bruce Willis and stuff.
in other planetary systems where you have a lot of giant planets, maybe more than we do here, those kind of interactions might be more common.
Yeah. And it's just God, whacking the cue ball and the 9-ball and, putting it, there's probably black
Yes.
holes. See, look, I've solved the mystery of the universe right here. I did it right here on the show. You've heard it first, people. So the black holes are the cue pockets of the billiards table. And God's like just trying to knock them in there. And that's why asteroids, asteroid shoot, that's God. He's knocked that thing. He's trying to hit that corner there of the black hole.
I love black holes.
Yeah.
Black holes
There you
are
go.
amazing.
The movie is great.
I wish, you saw the movie Interstellar.
I saw Interstellar and the Black Hole movie.
Yeah.
In the 80s.
That's a great, fairly recent sci-fi movie. And one of the big plot points is that there's a planet and it's around a star, but it's in the vicinity of a black hole. And that plays tricks with time and space and so on that are important for the movie. And I would love to know if there are really planets that are orbiting or near black holes. We don't have any yet, but we are in a position to start searching.
Mm.
Now, the
So that should be
techniques that we have for finding exoplanets, it's kind of a long shot, but some of them might apply to systems with a black hole. So, for
There you
example, just a couple of years ago, maybe even just 1 year ago, a sun-like star was discovered orbiting around a more massive black hole. And this was kind of the first time a normal star like the sun was found orbiting a black hole at such a distance that the star is not in any danger at all. But nevertheless, there's a black hole right there. And we are capable of searching for planets around that sun-like star using the same techniques we use for other stars. So it's possible that someday with systems like that, we will find planets that are kind of like the interstellar planetary system.
That was a cool movie, the different variations of the planet he was going to, And then it was kind of interesting. I saw the news items that India landed on the moon for cheaper than it was to make that movie. Which is,
I didn't know that about the cost.
Yeah. They did it for $75 million, and I think it cost more than that to make Interstellar. And so, it was a news item that went around that they landed on the moon for cheaper than what it took to make that movie. But he went to more different planets, so I think that was why it cost more.
Yeah.
So there you go, just like we were saying. But if NASA ever wants my help with the billiard theory of the universe, I'm always available. So
I'll make a note of it.
Let the higher ups know.
Mm-hmm.
I did flunk science though, and biology, and most of the English and second grade. I think that's the callback joke of the show we've been using for years.
You know how to ask good questions, and that's super important.
God playing billiards, which probably explains the first half of the Bible. Anyway, I don't know what that means. But this has been really insightful, a lot of fun, Josh. And people should read this, all the kidding aside and the entertainment aside. This is fun. I love, one of my favorite things to do is when I drive between Vegas and California. When I was a kid, as Boy Scouts, we used to go up in the UNS. And, once you can get outside of cities and lights and stuff, and you can really see the universe. You can see the Milky Way. You can see the Big Dipper and the Little Dipper, and you can really see the universe. You don't really get it when you're living in these big cities and areas, and it's just so beautiful. And it reminds you of how small your place is in the universe.
Astronomy is good for that. Yeah. I agree. Like the night sky is this just breathtaking work of art. Mm-hmm. That humans have enjoyed for millions of years, like until very recently.
Yeah,
we've been polluting the sky with our own light and hiding this Michelangelo type work of art that's over our heads.
Yeah, I can't see the stars anymore through the cold dusk. Hey, Beijing, keep it down there, buddy. So there you go. So my final question for you is, I'm single, I'm on Tinder, and the girls always want to know what your sign is.
Mm.
Is the exoplanets going to help me at all getting laid, or does my exoplanet do with my Aquarius sign there, or anything like that?
No comment.
Okay.
I'm not an expert in that area of exoplanet science.
And astrology, because I'm a water sign, eh?
Mhm.
And well, I need to find an exoplanet that's a water sign. I think that has to be how it's going to work there. Well, Josh, it's been fun and interesting and insightful and exciteful both. I don't know, insightful, is that a word? Clearly, I flunked English too. To have you on the show, very fun. And people should order up your book, learn about where it's at. This might be a great. Maybe you can get that Cameron dude, James Cameron, to make a movie about exoplanets.
That would sure ratchet up the interest level.
Maybe you can have those
Feature
Avatar
film.
people go to the exoplanet. Maybe they're on one.
Mhm.
You never know. That's Avatar 3. So thank you very much for coming to the show. We really appreciate it.
Hey, thanks for your curiosity. Really.
There you go. And give us your .com so people can find you on the interwebs, please.
I don't have a fancy website or anything like that. So
Okay.
you just search.
I've heard of
Josh
that
Winn,
Princeton place, though. Yeah.
You'll find me. And
Yeah. It's
you'll
been
find
around
the
for a
book,
little while.
The Little Book of Exoplanets. I hope some of your listeners will enjoy.
Pick it up and make it a great gift to give away for this upcoming Christmas. The Little Book of Exoplanets. The more you know, the more fun you know. And if you ever get tired, I lay up at night and I'm like, hey, what's going on, stars, eh? What's going on? And they haven't talked back yet, at least not to the one of the voices in my head. We can't talk about the other 10 personalities, but there you go. Order up wherever fine books are sold. And as always, folks, refer the show to your family, friends, and relatives. Go to goodreads.com/Chris Voss, LinkedIn.com/Chris Voss, YouTube.com/Chris Voss, and Chris Voss1 on TikTok. Thanks for tuning in. Be good to each other. Stay safe. We'll see you.